Hello and welcome to our channel. In this video of the machine learning series, we will learn about feature selection. So what is feature selection? Feature selection is the process of reducing the number of input variables when developing a predictive model. It is the process in which irrelevant features are eliminated, which reduce the accuracy of the model. For getting the best results in your model, the data you are using plays an important role. So feature selection helps in reducing overfitting of the model. It reduces the complexity of a model and makes it easier to interpret. It improves the accuracy of the model and it reduces the training time. So coming to feature selection techniques, they can be broadly classified into filter methods, wrapper methods, and embedded methods. We will be focusing on wrapper methods in this video. In wrapper methods, a model is trained multiple times using different feature sets, and the accuracy of these sets is then compared. Forward selection, backward elimination, and recursive feature elimination are the three techniques that come under the wrapper method. Forward selection. Forward selection is an iterative method which starts with having no feature in the model. In each iteration, features which best improves our model are added. This process is continued till an addition of a new variable does not improve the performance of the model. Backward elimination. Backward elimination starts with all the features. It then removes the least significant feature at each iteration, which improves the performance of the model. The process is repeated until no improvement is observed on removal of features. Recursive feature elimination. RFE or recursive feature elimination is a feature selection method that fits a model and removes the weakest features until the specified number of features is reached. Features in the model are ranked and the least important ones are recursively eliminated. The number of features to select and the algorithm used to help choose the features are the two hyperparameters used in recursive feature elimination. A hyperparameter is a parameter whose value is used to control the learning process. Now, we will look at the coding of recursive feature elimination as it is the most popularly used feature selection technique. So now let us see the code for RFE. First, we will be importing all the libraries that we need for the code. Then we will be loading the data set. This is a university admission data set having features such as GRE score, TOEFL score, university rating, etc. And based on these features, we have to predict if a person will get admission in the university or not. To this data set, we will be adding an extra column as result. For that column, we will be giving the condition that if the value for chance of admit for any row is greater than 0.7, then we will append the value 1 in the column, and if not, we will append the value 0 in the column. 1 stands for the condition that the person will get admission in the college, and 0 if the person won't get admission in the college. Then we will print the newly formed data set and we will use logistic regression for our prediction. So here I have passed two features, that is LOR and SOP, based on which we have to predict the result for our model. The data set is split into test and train data set, and the test size is 0.2, which means that 80% of the data set will be used for training the model and the rest 20% will be used to test the model. I have imported logistic regression from sklearn linear model, and we will fit our X-train and Y-train data in this model. We will then calculate the score for the logistic regression model, which we see is 0.78 or 78%. Now we will see how RFE affects our model's performance. For that, we will import the RFE library from sklearn feature selection I have passed all the features based on which we have to predict the result. And similar to the logistic regression model, I have split the data set into test and train data, 80% being the training data set and 20% being the test data set. So when we fit our training data set in the RFE model and calculate the accuracy, we see that it is 0.91 or 91%. So when we compare the logistic regression and the RFE models, we see that there is a significant increase in the accuracy when we use RFE.
RFE selects the best features to give the predictions of our model based on all the features that we have given as input. From this, we can conclude that RFE is a very efficient way to calculate the accuracy of the model. Thank you for watching the video.